Okay, fifth graders, so this lesson is going to kind of teach you the basics of polygons. And I know you've heard of them before, but I want to go through the attributes of a polygon with you because then as you go through this lesson, we'll go from 2D shapes to 3D shapes, and then we'll hit a little bit more on that volume of like rectangular prism. So a polygon is a plane shape, two-dimensional with straight sides. Triangles, rectangles, pentagons. A circle is not a polygon because it has curved sides. So if it has curved sides, if it's an open shape, it cannot be a polygon. And these are some examples of a polygon, and I like it because they use the words regular and irregular and complex and stuff like that. So you have a regular pentagon, an irregular pentagon. Can you guess why it's irregular? If you said because not all the sides are the same length, that was correct. You have a triangle, a concave octagon, which means it comes into a cave, an irregular hexagon, and a complex polygon. I thought this website was pretty cool because as you go, you can go from a triangle. We know that a four-sided shape is called a quadrilateral, a five-sided shape is a pentagon, and then as I change it, it goes concave pentagon. It's pretty cool. This is a pretty cool site. So hexagon, heptagon, octagon, nonagon, decagon, and even after that, I did not know what they were called, but 11-sided shape is called a hendecagon, and a 12 is a dodecagon, and a 13, look at this word, a triskaidekagon. Do you get it? Do you remember the triskaidekaphobia, the fear of the number 13? And then 14 is a tetracaidecon, Kaidecagon. Okay, try that a couple times. 14 is a pentadecagon. Hexakaidecagon. Look at this, heptadecagon. I didn't even know these. This is so cool. And then once you get to 21, it's just a 21agon and a 22agon. I didn't know that. See, so you could have a 35agon. So this was pretty cool. I like this website a lot. This is just mathisfun.com. I don't know if you can see that at the top here. Mathisfun.com. So what you're going to work on today is you have this is yours, polygon attributes, and it looks like this. You have two questions, right? So you have this, and then you have the second part. So it says, looking at the polygons below, Connor is trying to find all the ones that have two sets of parallel lines. Which polygon should Connor choose? Explain how you know. So then this is where we're going to talk about parallel lines. A parallel line and these are all the shapes. So a parallel line is a line that's never, ever, 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 ever going to cross. So like train tracks. A train track is what I like to think of because they have to be parallel. If for any reason a train track is not parallel and they start to go like this, what would happen? The train would crash. So a parallel line is like a set of train tracks. Like those are always going to be parallel forever and ever and ever and ever. So if we look at the polygons below, and I can present this, there we go. If we look at this set of polygons, which polygons should Connor choose? So he's trying to find all the ones that have two sets of parallel lines. Well, this is what we would do. So we would look at A. They're never, ever, 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 ever going to intersect. So A is correct. And I always like to think about it. I wonder if I can have a drawing tool. Pointer? See, this is new to me. So if I look at these lines, and I always think of if I pretended that they just kept going and going and going and going, would they cross? Well, if this one kept going and going, no, it wouldn't. These are kind of like train tracks. They would never, ever cross. But this one, so B, this would go over and up and up and up and up and up. But this one would end up crossing right about here. So that does not have two sets of parallel lines. It might have one, but it does not have two. And all of these are polygons because they don't have any curved shapes, or they don't have any curved lines. They're all closed figures. So these are all polygons. C, so your job is to go through to see which ones have two sets of parallel lines. Which of these polygons only have one set of parallel lines? So now you'll kind of do that same thing that we just did, but you'll go through it to find which ones only have one set of parallel lines. And then give two examples of shapes that fit under each attribute category below. So an attribute is just like a characteristic, something that the shape has that tells you what it is. So then explain how each shape fits under the categories. And these are really fun because we haven't talked about all these big math words yet, but we will. A quadrilateral, so we just talked about a quadrilateral has 4 sides with at least one acute angle. And number 2 is a shape with perpendicular lines. And this is where you'll put your work. So really quick, as you fill that out, I do want to go through. I found this really cool visual that will help us, so I'm going to send this out too, but it says, meet the polygon family, right? Think about your family tree. And in a polygon family, you have your triangle family, your quadrilateral family, and then just more relatives. So kind of your oddballs that don't really fit into a category. So in your triangle family, you have 4 different types of triangles, and it tells you right here. You have your equilateral triangle, which means all sides are the same. And one thing when it comes to triangles that we get to look at are the angles. So the angles on triangle A are all equal. So we call it an equilateral triangle. The sides are all equal and the angles are all equal. So a right triangle has a right angle, and this angle measures 90 degrees. And we haven't had a ton of time to talk about it, but that's okay. If you need to, you can go look up right angles, what does 90 degrees mean? But what it means in a 5th grade sense is that if I were to draw a square here, it would make a perfect square. It would be the same by same by same by same. It would make a perfect square. We have a scalene triangle, which means all the sides are different. Nothing is the same. All the sides are different. And then we have an isosceles triangle, which means 2 sides are the same. But with these angles too, and what it was talking about in where it says here with acute angle is an angle that measures less than 90 degrees. So if we have our perfect square, an angle that would not make a perfect square, that would be smaller than 90 degrees. So right here would be an acute angle. And I always think of it because it's just a cute little angle. It's a cute little angle, right? We do all of those fun things to make our brains remember things. So acute angle is less than 90 degrees. But we also have obtuse angles. And, excuse me, obtuse, I always think of, well, somehow I learned this, hang loose obtuse. So if you do like a hang loose sign, it's bigger than 90 degrees. So a 90-degree angle would be that right angle where you could draw a perfect square. A cute little angle is something that's smaller than 90 degrees. And then hang loose obtuse is larger than 90 degrees. So an obtuse angle is going to be bigger than 90 degrees. So these are the 4 types of triangles, and it has to do with the measurement of the sides and the measurement of the angles. So then in your quadrilateral family, you have parallelograms, rectangles, rhombuses, squares, and trapezoids. And the tricky part is sometimes they fall into different categories. So like you'll notice both E and F are both rectangles. So a square is almost everything, which is the crazy part. But so a rectangle is both E and F. A rhombus is G, I, and F. And we'll go through later where you characterize them and you go through their attributes to tell me what they are. But a parallelogram is E, F, G, I, and J. So I'm trying to figure out, do you think you can help me? What do E, F, G, I, and J all have in common that H does not? And it's something we just talked about at the beginning of this video. If you said parallel lines, 2 sets of parallel lines, in the word parallelogram, a parallelogram has 2 sets of parallel lines. And H would have intersecting lines, right? It would kind of be like an intersection of a street where they would eventually touch. And then other relatives, ones that are part of a polygon family, meaning they don't have any curved sides, they have straight sides, they're all closed shapes, but a pentagon, a hexagon, a decagon, an octagon, a dodecagon, and all those new words we just used. How cool is that? So your job is to fill these 2 sheets out, right? Connor's trying to figure out the ones that have 2 sets of parallel lines, and then you're going to draw and name 2 examples of shapes that fit under each attribute category below. On your weekly layout, I also did put a movie on there or like a quick song that just talks about polygons. And if you need help, just reach out and I am here. Okay, good luck.